Okay, so this is section 9.5.
You know what? I just have one more question.
Wait, what?
I'm sorry. I'm so sorry. Never mind.
Okay, so this is section 9.5, which is solving equations with scary fractions. Now, so far, all we've been doing is manipulating scary fractions, right? Yes? Now we're going to learn to solve equations with scary fractions. Should we solve a really easy one to warm up? Okay, let's solve a really easy one to warm up.
Is this one in the book or is it long?
This is just a random example, but the rest of them are out of the book. But here's a scary fraction. Yes? All agreed? Now, there's also an equation here, right? Scary fraction equals number. Right?
Is that a real one or did you make that up?
Yes to both.
What is
Yes, it's a real one. Yes, I made it up.
Like when you messed up on the math the other day, I'm asking, is this a problem from like a book or is this a problem from your head?
This is a problem from my head. Let's see if it works.
Okay, if it doesn't work, I'm going to be really upset.
It's going to work.
You promise?
Yeah.
Okay, let's go.
Okay, so let's see. How do I solve these? How do I solve things with fractions?
Do you want to make the 3 into a fraction?
Okay, I think making a 3 into a fraction is a good idea. And then I think we should say, okay, there's a bottom on this one, right? I'm not a huge fan of fractions in general. Yeah, most of you. So let's do this. Let's multiply by x minus 1. Good with me on that? So if I multiply both sides by x minus 1, what will I be left with on the left?
X plus 2.
Great. I'll get an x plus 2, and that'll equal, right? Really, I'm making a 1c there, right? The x minus 1s will be a 1c. I can cancel them.
3x minus 3.
On the right side, I get a, okay, there was a 3 over there, and then there's a x minus 1. Really, this is over 1, right? But I don't need that. Really, I probably didn't need to do the step where I wrote it as a fraction. Okay, so I got to here. Now, what do? Okay, let's distribute. So we distribute the right-hand side. What do I get? 3x minus 3. Now what? Okay, so let's see. I'm solving this equals that. So I've got x plus 2 is 3x minus 3, right? Now what?
Subtract 3 or add 3.
I don't know. Get the x's by themselves and the numbers by themselves, right? So there's a couple ways to do that. I'm going to do this, I guess, the easy, what I think might be the easy way. I'm going to subtract x from both sides. So what will that leave me with? On the left, I've got a subtracting x, so I get a 2 on this side. And on this side, I've got 2x minus 3. Right, I had 3 x's. Somebody came and took one away. That leaves me with 2 of them. And then we didn't change the 3's. Okay, then I add 3 to both sides. And so I'm left with 5 equals 2x. Okay, so I divide by 2. You get 5 over 2 is x. Bam,
Do you
done.
want us to reduce it or no? No. You don't like us to
But we want to add 3.
So what do you mean reduce?
2.5.
to write 2.5. I don't like you to write mixed numbers. Sure. I would prefer if you lived in fraction land, but you can live in decimal land if you want. Just make sure that when a fraction isn't exactly equal to decimal, you write approximately equals to. Right, like a third is not 0.66, it's approximately 0.66. You guys cool with this? Okay, great. So we got a number out of this one. Neato. We have solved our first equation involving scary fractions. So where's the 3? This means, right, really what I should think maybe here, right, is I should think, all right, this is a function, right? And I'm saying which x has f of x equals 3, right? Does that make sense? This is this question. Okay? So the answer is x is 5 halves has f of x equals 3. So what I found out was f of 5 halves is 3. Yeah, and if you want to check your answer, check your answer. Yeah, plug it into all the x's. It'll be weird, right? It'll be one of these fraction things, right? Like it'll be a super fraction because there's a fraction in the top, fraction in the bottom. But we know how to deal with those. You guys see that? Okay, so yeah, if we plugged 5 halves in here, we would get 3 out. That would give us a nice check. Cool? All right, should we do a harder one? This was not hard. What was this? What was the trick with this, actually? Yeah, I realized that. Okay. What did I do to get from the step where I had a scary fraction to the step where I didn't have a scary fraction anymore? Yeah, I multiplied by the common denominator, the common bottom from both sides. Right, I wanted to cancel this guy, so I multiplied both sides by x minus 1. I got left with the top because I multiplied by the bottom. You guys see that? Okay, so in general, this will be the trick. Find the common bottom between both sides, multiply by it to clear the bottoms. Right? That'll get rid of the fraction. Then you'll be left with something that you can actually solve. Okay, so let's try a scary one. I'm going to put some words here too.
Is this one yours too?
No, this is out of the book. So there is a word of caution here. This is why. Okay? Okay, so this one's scary, yes. Scarier. Okay. Let's see. Can you guys help me out with this? What do I need to do first?
Get rid of the 2.
Yeah, I want to make the right side one fraction, or at the very least, find the common bottom over there. You guys see that? I don't really need to make it one fraction, but I better find the common bottom. So let's see. I'm looking for the common bottom among everything, right? So here I've got an x minus 4.
This is 4 minus x is the same thing.
4 minus x is almost the same thing. What's it off by?
Negative.
A negative sign. So my first step would actually be to take this whole thing and just rewrite it as x minus 12 over x minus 4 equals what over x minus 4? negative 2x. That's factoring a negative out of the bottom. And then I've got a plus 2. I should probably write the 2 as a fraction. What's the bottom? 1. You guys see this? Okay, so at this point, I want to think, okay, what's the common bottom among all the fractions, both sides?
Minus 1.
So the common bottom is x minus 4. Okay, see that? So my next, yeah.
I don't see where we got a negative 2. I'm sorry.
So 4 minus x, if I flip the signs on both pieces, that's x minus 4, right?
Okay.
So I'm thinking, okay, kind of off to the side, I'm thinking 4 minus x is minus 1 times x minus 4. And then I say, okay, so I get a minus 1 out here. Well, I may as well put the minus 1 on the top. Really, so I'm thinking 2x over x minus, over 4 minus x is 2x over negative 1 times x minus 4. And I'm saying, okay, it doesn't matter where the negative 1 is. I may as well put it in the top.
Okay.
Right, dividing and multiplying by negative 1 is the same thing. Cool? All right, so my common bottom is this. So what do I do now? Okay, I could either make them all match, or I could just zap them. Multiply by the whole common denominator, the whole common bottom here. So if I multiply this whole thing by the common bottom, I've got x minus 4 times x minus 12 over x minus 4 equals this stuff, minus 2x over x minus 4 plus 2 over 1 times x minus 4. You guys with me on this? Okay, now what? See, that's a cancel. That's a onesie, right? Guys all see that? Okay, what else?
X minus 4
Does this cancel with that? Yeah, there's an addition in there, so what do I need to do? Yeah, I should distribute first, then maybe I can cancel. So let's see, I've got a x minus 12 equals, so this step is distribute, right? And on that side I've got a minus 2x over x minus 4 times that x minus 4 plus what? Two over 1 times, perfect, times x minus 4 is 2x minus 8. It's cool with that? That's distributed again through x minus 4. Yeah?
Doesn't matter which x minus 4 you use to begin with instead of starting with that side, to start with the other side.
Oh, yeah, no. Go for it. Multiply on the other side.
I'm sorry, can you do this, like the x cancel like that? But the other side I can
Yeah, so we need to make sure that we distribute. Right, we've got x minus 4 times something plus something else. So that's the first stuff times an x minus 4 plus the second stuff times an x minus 4. Would it have made more sense if I wrote this? Right? Okay, so let's see. This is a x minus 12 equals, okay, what else have I got? What can I cancel? Those two guys are a onesie, right? Okay, so I got a minus 2x plus, and then when I distribute the 2 through that, what do I get? 2x minus 8. Okay, so now what? Yeah, there's a minus 2x, a plus 2x. Those sum to 0, right? So this is a 0. So I can drop those, right? So I get an x minus 12 equals minus 8. Now what do I do to both sides? Add 12. Okay, so I get a x is 4. Okay, here's the word of caution. Did you check? Did we check before on the other one? Oh, dang it. Probably should have. Be really cautious with these. Why are you being cautious? X is 4, right? That's my solution. Can I plug x is 4 in here?
Yes.
No.
Yes, you can.
It's gonna be 0. No.
It's 0 here and there, right? Where are those that's a problem? Oh no, they're on the bottom, right? So I got something over 0 equals something over 0, but I'm not allowed to divide by 0. You guys see that? So I found this solution, right? But this is not in the domain.
Is it still right though?
No,
No.
it's not a solution. This is what's called an extraneous solution.
So that's the wrong answer.
Yeah, so the answer is what's the answer?
4 is not all those.
There isn't a solution. Then maybe in parentheses, x equals 4 is an extraneous solution. You see that? Yeah.
You have to write that on the test, it means that x equals 4 is not a solution.
So if you write x equals 4 is not a solution, have you conveyed to me that there is no solution? You guys see that? What we found is we went through this and we found that the only possible solution was x is 4, right? But x is 4 doesn't fit either. So what I found out is there isn't any solution. You guys see that? So on my example, I screwed up. I should have gone back through at the end and checked 5/2 to see if I was dividing by 0. You guys see that? I don't have to check if f of 5/2 is 3, but I should check that f of 5/2 is actually defined. Does that make sense? That's the problem here, right? I have here some function f equals some function g. And I said, okay, x is 4 is the answer. Oh, except f and g are both undefined at 4, so that doesn't make any sense. You guys playing along? Okay, so we can see that somewhere else here. So where was that extraneous solution somewhere else? At the beginning here, we multiplied both sides of the equation by x minus 4, right? If x is 4, what's x minus 4? 0. So we multiplied both sides by 0, right? Is it any wonder that we got a solution out of that? Well, 0 is still 0, right? You guys see that? So we sort of did this to ourselves when we multiplied by this. We kind of introduced that solution because we multiplied both sides by something that when we found our solution was 0. Yeah?
not to be lazy, but with it, if it was x minus 3, would 3 not be the solution?
So if I had x minus 3's here, or 3's instead of 4's on the bottom, when I got to the end, if I found x is 4, that would be fine, right? Because I'm not dividing by 0 then. Does that make sense?
Yeah.
I'm checking my solution is actually a defined spot in my equation. You guys want to see another one? Yeah. Okay. Let's try another one. Oops. Black. Black. Okay.
Is this one in the book too?
This is in the book too. Why are you guys obsessed with what's in the book?
Because then it gives repeated.
Oh, yeah, these are the examples in this section. Okay, so I start with this example. Okay. What's the first thing first?
Panic.
What do I look for? Panic. Good. Excellent.
And then stop panicking.
Okay, so once I've not panicked anymore, what do I look for? Yeah, I should look for a common bottom, right? Okay, so I look at this junk and I think common bottom is x minus 1 times x. You guys see that? These two pieces have a bottom of x minus 1. This one has a bottom of x. That means my common bottom is x times x minus 1. You guys cool with that? All right. So what do I multiply by?
X minus 1. What did you say? Where? Another one? X minus 1 minus that one.
Yeah, multiply by all this stuff, right? Multiply by the common bottom and it'll clear the fractions. Okay, so we're going to multiply by x times x minus 1. Okay, so we get, all right, so I've got x times x minus 1 times x over x minus 1 minus 2 over x. And this is going to be equal to x times x minus 1 times 1 over x minus 1. You guys cancel some stuff? Just go for it.
You don't have to do all that.
Not quite.
Because the x is at the top of the bottom, the one that you're multiplying.
Oh, this guy?
Uh-huh.
That's the top. Or I'm multiplying by it. I want it to cancel with the bottom. So let's see, what things can I cancel right away?
X minus 1.
Okay, there's a x minus 1 here. Cancel those. Is this what you're asking about? Can you eyeball the cancels? Yeah, go for it. Okay, on this side, what do I get?
Cancel that.
Okay, careful. Don't cancel this and that and this and that.
No, just cancel.
You need to distribute first, then cancel. So you get x over x minus 1 times x minus 1 minus 2 over x times x minus 1 equals, what's on the right hand side? That's x. Okay, now where are the things I can cancel on the left?
X minus 1.
There's a x minus 1 in the first bit and a x in the second bit. You see that? So all told here, I'm going to get, I got a x squared minus 2 times x minus 1. Yeah, make sure you're distributing on that one. And that's equal to x. Cool with this? So I get a x squared minus 2x plus 2 equals x. Cool. You guys ready for your quiz?
Guess the answer?
No. Solve this part for your quiz. You can't solve this using the new stuff. You have to solve it using the... Yeah, so this is a problem out of chapter 7. Okay, so let's solve this. How do you solve something like this? Panic, right?
Very much.
So there are 3 maybe ways to solve this. First, I would recommend putting this over there with the other x's, right? So subtract x from both sides. Get x squared minus 3x plus 2 is 0. Right? Okay, now you can either quadratic formula this or complete the square or factor and use the 0 product rule. I would recommend towards factor and use the 0 product rule. So what do you get when you factor this thing? -2, -1, right? I need multiply to 2. That sounds like 2 and 1. And add to -3, so they're minus and minus. Right? So this tells me that my 2 solutions are x is or x is 2 or 1. Okay? Right? Going back to the problem we were trying to solve, right? This thing from 9.5. Which one of those is a solution and maybe both are? No, just 2 is the solution to the 9.5 problem. I didn't expect you to get that, right? This was not the quiz. The quiz was to here. But the answer to the 9.5 problem that we started, solve this thing, is x is 2 is a solution. So solving 9.5, x equals 2 is the solution. Right? Maybe comma, x equals 1 is extraneous, is an extraneous solution. What's that? Yeah, okay, so let's grade the quiz.